Now, in this particular exercise, we'll be writing the algorithm to translate the pumpkin. Now, for that, I need two constants which we'll be adding to the center of the pumpkin. So, we'll declare them as speedx of type CG float, because uh, CG point runs on the parameter called CG float. So we have to declare them explicitly as CG float. So we are given speed x and speed y as a value 3.0. Now in physics we have a concept called vector. The vector has a magnitude and a direction. So if you want to implement physics logic, every variable you declare is a vector, because the sign indicates which axis the particular point will get reflected. Now if I say I want to update my center of the pumpkin with speed x and speed y regularly, it will move diagonally downwards, because x is incremented in right and y is incremented in downward direction. So when it hits the boundary, I want the pumpkin should go back and bounce back and goes in a reverse direction. In that case, I don't have to do anything. I just have to change the speed x and speed y sign. So if it's moving with the +3 in an x direction, it will start moving from the -3. So automatically it will move from right to left, and when it reaches the left boundary, it will move again. I'll say speed x equal to minus speed x. So -3 will becomes again +3, and again it start moving from the left to right. Similar equation will happen for the y-axis, top to bottom and bottom to top. So that will be happening in the update game. So I'll just comment the println and I'll say I'll update this pumpkin center by saying pumpkin center equal to CG point make. I'll say pumpkin center dot x plus speed x. And I'll say pumpkin dot center dot y plus speed y. Now if you see this update game is keeping calling, I'll just stop this. Now once the center is updated, you have to check for the boundary condition. So if a pumpkin goes outside the boundary, you have to reverse the pumpkin. So you say if pumpkin dot center dot x, if it's less than or equal to 0.0, or pumpkin dot center dot x if it's greater than or equal to 320, then you will say speed x equal to minus speed x. So you are just changing the sign and not the magnitude. So what will happen in this case, your +3 will become -3, -3 will become +3. Similarly, you want to have condition for your y-axis. So once you have done this, you run your project and you will find pumpkin is moving freely on the screen. But if you see, pumpkin goes half the way inside and then bounce back, because you are checking for the center. You have to check for the extreme boundary of the pumpkin view. So in that case, we will be using the frame property of the view. So instead of checking for the center, I'll say frame dot origin dot x, because we have the every view has a top left corner. So if a top left corner goes beyond, and then I'll say plus the width by 2 to get the extreme corner right corner. So I'll say pumpkin dot frame dot size dot width by, if that's greater than the 320. So I can check for the directly the screen size. So self dot view is a full screen, so I can always check directly for the view screen Similarly, I'll say instead of center.y, I'll say frame dot origin dot y, and for y I'll say, for the bottom condition I'll say pumpkin dot frame dot pumpkin dot frame dot size dot height by 2. And instead of 480 I can use the controller's view height with a full screen. So let's see height. Now once you run this project, you will get the desired output. So now if you see, pumpkin is colliding exactly at the corners. So in the next exercise we'll see how, when we'll interact with the pumpkin, it should increment the score and increase the speed, and when I miss the pumpkin, the life should get decremented by 1, and when a life equal to 0 we should call game over.